Hey guys, welcome to another UH. I know it's been a while. This is integration by parts. So there's a formula to this, guys, and we're just going to go ahead and tell you how this formula looks like. Whenever you can't do U substitution and you're looking at it and you're like, okay, what can I do? Because I can't do U sub. It might be a partial fraction one, but we haven't covered that yet. So here we go. So there's a formula here. So if I have something like in something that looks like integral of u dv, I can write this as u times v minus integral of v du. And actually, this formula comes from, you can derive it from the product rule. But let's go ahead and just use it, guys. So look at this one here. So obviously we know we're going to do integration by parts because that's what this quiz is called. But let's say we didn't know that. Well, we can't do U substitution because that's to the 6, and this is the power inside the argument of ln is to the 6, and I don't have a power of 5 here. So I can't do U sub. So the trick is to use integration by parts. And we have an acronym called LIPIT, and we're going to use this. This will help. Probably 90% of the time this will work. So this is what's going to help you to determine what's going to be your first letter, the U. So the L stands for, excuse me, the L stands for logarithmic. The I stands for inverse, like inverse trig or functions. The P stands for polynomial, so that's just your regular polynomial. The E stands for exponentials, and the T stands for trig. So this is what you're going to use for 90% of the time, guys, and it helps. I don't know if it's on certain math books. I read it in a math book, and I don't know if other textbooks have it like that acronym LIPIT. If you Google it, I'm sure it comes out. Okay, so what I'm going to do here, I'm going to do the UV, integration by parts. So I'm going to write U du, and I'm going to write V dv. So according to my LIPIT formula here, I'm going to go ahead and make the logarithmic the u. That's what I'm going to do first. So the ln of x to the 6. So then when I take the derivative, that's going to be, what's that? 1 over x to the 6 times 6x to the 5th dx. So again, rewriting what du is, these 5's cancel out. You get 6 over x dx. All right, so then that means the 4x coupled with the dx is my dv. So 4x dx. So then that means my v had to have been a 2x squared. See, you just do antiderivative of that. And now here we go. So according to my formula here, the integral u dv is the same thing as uv times minus the integral v du. So I'm going to go u. So u is ln x to the 6. And then I'm going to go v, 2x squared, minus integral. And I'm going to do minus integral v du. So v is 2x squared. Du is 6 over x dx. So let's fix this now. So let's see, 2x squared ln of x to the 6 minus this x cancels out with one of those x's, and you get minus integral of 12x dx. So now here we go. We're going to do antiderivative finally. So this just says that 2x squared ln of x to the 6 minus add 1 divide by 2. So that's going to be 6x squared and then plus c. And there it is. All right. So again, I use my little LIPIT. By the way, you will know if you messed up because you'll either get something that keeps growing in power, like when you do the integration by parts, or it just will not work. And then you have to switch your variables. But if you use LIPIT, it's going to work 90% of the time. So again, I have a 6x and e to the negative 5x. So the 6x is going to be your u. So I'm going to write, let me go ahead and switch colors, guys, so we can, because it's probably going to be pretty tight here. U is going to be 6x, and then so u du, and then v dv. So then 6 dx. So then that means that my dv was, let's see, if u was 6x, then my dv is just going to be e to the negative 5x. E to the negative 5x dx. So then my v had to have been, let's see, negative 1/5 e to the negative 5x. Okay. How are we feeling so far, guys? Are we feeling okay? Okay. I can't really hear you guys, but here we go. So uv, so 6x times negative 1/5 e to the negative 5x, uv, minus integral v du. So v was a negative 1/5 e to negative 5x, and then du was 6 dx. And yeah, we can simplify as we get better, as we get more experience on this. So let's see, negative 6 over 5 x e to the negative 5x. Negative times a negative is a positive. Integral, maybe put the constant on the outside. So 6 over 5 integral e to the negative 5x. Oh, the x should be in the top there. dx. So let's see what we have. Negative 6 over 5x e to the negative 5x plus 6/5 times a negative 1/5 e to the negative 5x plus c. And then, of course, I'm not insulting your intelligence. I know you guys can simplify that, but finishing it off. And we have, let's see, 5 times 5, 25. So 6 over 25 e to the negative 5x plus c. And there it is, guys. All right, let's keep going. So again, on this one, we're going to set u equal to 2x. And we're going to set dv equal to sine 3x dx. So I'm going to go, again, I'm using Lipit to help me out there. So u equals 2x. Oh, let's use a different color, right? That way we can utilize, well, I guess it won't help. It doesn't matter. U equals 2x. So du equals 2 dx. V dv. dv is going to be sine 3x dx. Sine 3x dx. So that means the v has to be a negative 1/3 cosine 3x. Because the derivative of cosine is a negative sign, but I don't have a negative. So there we go. So let's keep going. And let's use our little formula. So uv, so 2x times negative 1/3. Sorry, guys. I'm looking at my phone here because it's ringing. Cosine of 3x minus integral of negative 1/3 cosine 3x times 2 dx. So uv minus v du. Let's see. So now I'm going to have negative 2/3 x cosine, that's an x, cosine 3x plus, and then I guess I'm going to move that 1/3 out first, or the 2/3 out, guys, first. 2/3 integral cosine 3x dx. Okay, and finally, let's see. So I have a negative 2/3 x cosine 3x plus 2/3 times, the antiderivative of that is 1/3 sine 3x plus c. Yay! So negative 2/3 x cosine 3x, and I see that I didn't put the parentheses there, plus 2/3 times 1/3 is 2/9 sine 3x plus c. And then there it is. I am going pretty fast, guys, so I'm not going to deny, like maybe you're like, oh my God, Chavez, slow down. I am doing this formula over and over and over again. uv minus integral v du. uv minus integral v du. Over and over and over again. So I am going pretty fast, so I'm not going to deny if you're like, oh my God, this guy's going fast. I am. So I'm going to see if I can slow down a little bit. All right, notice this one, I have a definite integral. So let's just go right into it. Again, I use my little Lipit formula. I remember this one taking a while, this one here in particular. I think I had to do it twice. You'll see what I mean. So I'm going to say, first get around, I'm going to say that u has to equal 8x squared. So in a little bit we'll do the du. V and dv, excuse me. So my dv is going to be equal to sine x dx. So derivative of 8x squared is 16x. So antiderivative of sine x is a negative cosine x dx. Now, The reason why you want to make the polynomials the u guys and not the trig is because the trig is just going to be going back and forth, sine, cosine, sine, cosine, sine, cosine. And so you want the u to be a polynomial that every time you're going to take a derivative, it's going to go down by 1. So you're going to see I'm going to have to do this again. So check it out. This is going to equal to uv 8x squared times negative cosine x uv minus integral of v du. So integral of v, so v is the cosine x du, so I'm going to write it as 16x negative times the negative is a positive, so there's my positive right there, cosine x dx. Now notice, I'm not done. You're going to have to do another integration by parts there, guys. So I'm going to circle it in red. And whatever you see in red is going to be that integration by parts. So here we go. I'm just doing this in red. So I'm going to set my u. For this guy now, I'm going to set my u equal to 16x. So u, I don't want the v in the bottom. I want the d in the bottom. U du and then v dv. So obviously the derivative of 16x is just 16, so 16 dx. And then my dv has to be my cosine x dx. Cosine x dx. So my v has to be sine x. The derivative of sine is cosine. Okay, so having said that, just for the stuff in the red, let's see what we got. So let's see, uv, so 16x times sine x. That's my uv. Minus integral of v is sine x du. 16 sine x dx. There we go. Now we got an integral that we can solve for. So finally, oh, by the way, all of this has the 0 to the power over 2, and so does this. This is 0 to the power over 2, and so does this right here in the beginning. That's 0 to the power over 2. Everything that does not have the integral symbol has that limit right off the bat. All right, so finally, putting it all together. Here we go. We're going to put it all together. So finally, we have this. I'm going to put bracket 8x squared negative 8x squared cosine x plus, okay, so this in red is this right here. So plus 16x sine x. And then look, we can do the antiderivative of that real quick. Antiderivative of that is, antiderivative of sine is a negative cosine. Negative times negative is a positive. Plus 16 cosine x. And all this is evaluated from 0 to pi over 2. Okay, so now let's go ahead and plug in pi over 2. You got to know a little bit of pre-calc. Cosine of pi over 2 is 0, guys. So the first term goes away. So here's what I have. So I have 0, and then sine of pi over 2 is 1. So you have plus 16 times pi over 2. And then cosine of pi over 2 is 0 again, so plus 0 minus, and then when I plug in the 0, cosine of 0 is 0, but I have an x squared there, so my first term right there is going to be 0 again because of that x squared there. So 0 plus 0, and then that looks finally like plus 16. So my final answer, let's see, 2 goes into 16 8 times. So it looks like it's going to be 8 pi minus 16. All right, here we go. Let's go to the next one. Sorry, guys, I'm hearing some cracks, and I'm not sure if all those little cracks are like from the light that I have above me, or there's some type of electrical shortage, so I'm a little scared. All right, question 4. Yeah, it looks like I'm going to have to do this twice again. So I use my little lippet to figure out what's going to be my u first. Logarithmic, inverse, polynomial, exponential, trig. So exponential comes before trig, so I'm going to do the u as the exponential, guys. All right, so here we go. U equals 4e to the x. So u du v dv, and then the dv has to equal cosine x dx. All right, so now that I know that, that means that my v has to be sine x. And, well, because u is 4e to the x, that means that du is going to be 4e to the x dx. All right, so now we're in business. All right, so let's go ahead and see what's up. So uv, so I'm going to write 4e to the x times sine x minus integral of v du. 4e to the x v du sine x. Okay, now it looks like we're just going to keep toggling back and forth over and over again, which is fine. As long as I can get it to look like 4e to the x cosine x again, which I am. I'm about to do that right now. So I'm going to circle this in blue. And I'm going to write u is equal to, again, 4e to the x. Why didn't it? 4e to the x. And then du is equal to 4e to the x dx. And then v dv. dv is going to be equal to sine x dx. So v has to be equal to cosine x. Negative. Because the derivative of cosine is negative sine. So I want a positive. So there it is. Okay. You guys ready? Yeah. All right. When I do that antiderivative, here's what I have. uv, 4e to the x times a negative cosine x minus integral of v du. So v is negative, and then negative times the negative is a positive, so it's going to turn to a plus 4e to the x cosine x. Okay, now remember, there's a negative in front of that. So finally, I'm going to see if I can write it all over here. So I'm going to hear, so finally, here's what I have. And I'm going to start way over here on the left-hand side. So this is what I'm writing first, right here. Integral 4e to the x cosine x dx equals, well, what does it equal? It gives me this first one here. So 4e to the, I guess I don't need parentheses if I'm already knowing that I'm multiplying. 4e to the x sine x, and then minus, and then minus a negative times a negative, that's going to be a plus. So plus 4e to the x cosine x. And then when I do the antiderivative of this, let's see, well, I'm not doing antiderivative of that, but I'm distributing that negative. Minus integral 4e to the x cosine x dx. Okay, notice I have 4e to the x cosine x dx, I have 4e to the x cosine x dx. I'm going to add them, and when I add them, well, that's like you have two of them now. So I have 2 of the 4e to the x, 4e to the x cosine x, sorry, which equals 4e to the x sine x plus 4e to the x cosine x. Okay. So look, I'm going to get rid of that 2 by just dividing. Because I just added. I had one integral of 4 to the x plus another integral of 4 to the x. So now, my integral 4e to the x cosine x dx is simply equal to 2e to the x sine x plus 2e to the x cosine x. There it is, guys. Kind of cool, huh? I will admit it is a little tough in the beginning. So maybe the fact that we're barely going through this might, hopefully I didn't confuse you guys too hard. All right, so here we go. We got this one here. Oh, I'm gonna turn on the lights, guys. All right, so we got 7, arctan, and it looks like, at first it looks like, oh my god, it's pretty tough, but it's actually not that bad at all. So here we go. My little lipid formula, excuse me. The 7, I'm just gonna, I guess I'm just gonna leave, no, don't leave it, don't leave it alone. So my u, the I is the inverse, so the arctan is an inverse function. So I'm going to set my u equal to arctan. So that means that du has to be 1 over 1 plus x squared dx. And then v and dv. So then that means my dv has to be 7 dx. So that means my v has to be 7. So under that circumstance, let's go ahead and do this right here, uv. So u is arctan. So u is arctan. And then v is 7. Hold on, I messed up here, guys. I messed up. If dv is 7dx, then that means that v is 7x. The derivative of 7x is 7. So there it is. Now we're back on neutral. So that's the problem with going fast. But I caught it though, so we're good. So arctan x times 7x, I think we're back in business there, minus the integral of v du. So let's see, 7x over 1 plus x squared dx. I can already see that that was together, guys. If you want to put it in 2, that's fine. Now, you no longer have to do the integration by parts on this part, because that looks like u substitution, like just flat out u sub. So, doing flat out u sub, I'm just going to say that u has to be 1 plus x squared. So du can be 2x dx. So I'm going to put that 7 on the outside. I need a 2. If I put a 2 there, I put a 2 on the outside. And now there it is, guys. So I'm going to just do the antiderivative of that. So I have 7/2 integral of 1 over u du. So that's just ln. So 7/2 ln. Did I have any limits on the top? No. So I should be putting an absolute value, but because u is 1 plus x squared, it's always going to be positive. Plus c. All right, now we're ready. So my final solution. So final solution is going to be arctan of x times 7x. Maybe put the 7x in the front there. Minus 7/2 ln of 1 plus x squared plus c. All right, let's go to the next one. Ooh, that one was tough. This one was real tough. What I want is I want that to have the same degrees. So we're going to first do this. Integral x times x squared cosine of 8x squared dx. Okay. So now that I have that, I'm going to do a u sub, but it's not necessarily u substitution. I don't want to use the letter u because I'm doing integration by parts and we use the letter u all the time. So I'm going to say w. I'm going to say that w is equal to x squared. So then that means that dw is equal to 2x dx. Okay, I can live with that. If dw equal to 2x dx, well, I almost have 2x dx. I need to put a 2 there. If I do that, I put a half. So 2x dx is my dw, and then that x squared is just a w, and that x squared is just a w. So here's what I now have. 1/2 integral, and then I have the 1/2 on the outside, w, and let's see, cosine 8w dw. All right, now I'm going to do integration by parts. Now I'm going to say that u is equal to w. So then that means that du is just dw, and then v and dv. So then that means that dv is cosine of 8w dw. So that means that v has to be 1/8 sine of 8w. And if we're having a hard time with doing, like, going backwards, guys, it's probably the rust. So you just got to get back into it and do a whole bunch of these so you can get better back at it. So you guys can get back. Oh, man, I can't talk today, man. What the heck? So you guys can get right back at it, guys. So there it is. Let's see. Am I missing anything? Yeah, if you try to do u substitution, or if you try to do integration by parts immediately, you're going to get stuck immediately, because then you're going to have a dv equal to cosine 8x squared. And then how do you do antiderivative of that? Like, obviously, there was an x squared in there, and then the product rule comes in and all that good stuff. So this is the best route, guys. So here we go. So I have that half, so 1/2, and I'm doing integration by parts for this right here on the inside. So 1/2, and then, so let's see, uv, so w times 1/8 sine of 8w. Okay, and that's that part, minus 1/8 integral. I'm just doing v du, guys. There's the 1/8, and I'm just taking it on the outside. Sine of 8w dw. All right, there we go. I'm going to distribute the half. So 1/2 times 1/8 is 1/16. So I have 1/16 w sine of 8w minus, so look, 1/2 times 1/8 is 1/16. So I have 1/16 here. And then when I do antiderivative of of sine 8w, that's another 1/8 here in the front. Does that make sense, guys? All right, hold on. And I did mess up, huh? Or no? Yeah, this, hold on. uv minus v 1/8 du. No, we're good. I didn't mess up. Cosine 8w. Yeah, close. Okay, so 1/16 w sine 8w, and then 16 times 8 is 128. So 1 over 128 cosine 8w. Remember what w was? W was x squared. So 1/16 x squared sine of 8x squared minus 1/128 cosine of 8 x squared plus c. Yeah, that one was tough. So maybe go through it one more time, guys. And sorry if I went through it really fast. Really fast. All right, now we're getting into really hard ones. Well, yeah, we should do it. Number 10, I'm just going to exempt this one. That one's funky. But all right, question 8. All right, question 8. You have to just transform it completely. So let's take this into account. So I see the 6 there, cosine ln of x, and let's just make sure that we know what we're doing here. So I'm going to transform it completely. Again, I'm going to use w. So I'm going to say w equals, what am I going to say w equals? I'm going to say w equals ln x. So if w equals ln x, that means x equals e to the w. So dw equals 1 over x dx. I'm not going to do the whole, there's 1 over x dx, whatever, blah, blah. So I'm just going to multiply by x both sides. So this means that x dw equals dx. I just multiplied it by x to get rid of that 1 over x. Now remember, x is equal to e to the w. So e to the w dw equals dx. So I'm just going to substitute dx for e to the w dw. And I guess I'm going to put the e to the w here in the front. So here's what I now have. So this statement here is equivalent to 6 e to the w cosine w dw. Okay, so as long as we know that those are equivalent. All right, now here we go. Now I'm going to do my u sub, guys. I'm going to say that u is equal to 6e to the w. So du is going to be 6e to the w dw, v and dv. So dv is cosine w dw. It's left over right here. So that means v has to be sine w. All right, let's start. uv, so let's see. 6e to the w times sine w, that's my uv, minus integral of v du, sine w, 6e to the w. So I'm going to put the 6e to the w first, guys. 6e to the w sine w dw. All right, again, with this right here, that's a w there. I'm going to have to do it again. But remember, just like last time, look, it's just going to keep toggling. It's going to keep going 6e to the w, and instead of sine w, it's going to go to cosine w, which is what I want. I want it to look exactly like that because I'm going to do, what am I going to do? I'm going to do exactly how I did number 5. I'm going to do exactly how I did number 5, where I'm going to add them up. All right. But this time we're gonna have to do something a little different. Hold on. No, we don't have to do anything a little different. Okay, we're gonna do everything exactly the same. All right. So again, with this one now, I'm gonna do another U sub. So again, my U is gonna be 6e to the W. So du is going to be 6e to the w, dw. V dv. My dv is going to be this time sine w dw. So my v has to be a negative cosine w. All right, I'm just doing this part, just that part right now. You know what? Let's just do it all because we're going to need it all anyways. So here's my equal sign, and it's that equal sign right there. So here we go. I have 6e to the w sine w minus, let's see, minus, and I'm doing this integration right here. I'm doing this part. So u times v, so 6e to the w times a negative cosine w minus, and then integral v du. But notice that my v is a negative, so negative times a negative is a positive, so there it is. 6e to the w cosine w dw. Okay, that's in the brackets. I'm gonna go ahead and add these up, guys. So here's what I have. So here's what I have from scratch. Integral of 6ew cosine w dw equals 6ew sine w minus 6e, well, negative times the negative is a positive, so plus 6ew cosine w minus integral 6ew cosine w dw. So here it is. This guy here and this guy here. I'm going to add them up. I'm going to move this to the left-hand side, so I'm going to have two of them. So when you have two of them, here's what you're going to have. Integral, you're going to have 2 of the 6ew cosine w dw equals 6ew sine w plus 6ew cosine w. If I have 2 of them, I don't want 2 of them, I just want 1. I just want 1. So I'm going to divide by 2, divide by 2, divide by 2. So integral of 6ew cosine w dw is equal to 3ew sine w plus 3ew cosine w. Finally, remember that we said that this here was equivalent to 6 cosine ln x dx. So, there it is. This is my answer here. Replace the EW with x. So 3x sine, and then w was ln x, sine ln x plus 3x cosine ln x. And there it is, guys. And yeah, that one was tough. It was real tough. All right. You think we can handle one more? Yeah, let's handle one more. And I'm going to, if question 10 is still exempt, I'm just going to need that space to write, guys. All right. So let's just start. This looks like we're just going to go right into it. I think we might have to do it twice. It looks like we're going to do it twice. U is equal to 2x squared. So then that means du is equal to 4x dx. And then v and dv. dv has to be e to the negative x dx. And v has to be e to the negative x. In case you're wondering what I'm using Lipit. Logarithms, inverses, polynomials, exponentials, trig. So whatever one comes first is what I'm using to pair up to make my u. All right, so from there, let's go ahead and see if we can start with the first batch. So let's see, u times v, so I'm going to write 2x squared times e to the negative x plus, or no, minus the integral v du, v du, hold on. Oh, yeah, I almost messed up. Okay. Because dv is e to the negative x, v is a negative e to the negative x. So v du, so negative times the negative is a positive, and then 4x e to the negative x dx. I just went ahead and moved the negative on the outside. Hopefully no one's confused there, guys. We have limits, so if you want, you can already start searching that one from 0 to 1. I'm going to continue. So again, on this one, we're gonna make on this one right here. Let me circle it in red and then do that part in red. I'm gonna set my u equal to 4x. So then that means du is equal to 4dx, and then v and dv. So my dv again is e to the negative x dx. So that means my v has to be a negative e to the negative x. Okay, we're ready. Let's go from the top. So we have 2x squared e to the negative x. Let's see, plus uv. So 4x times e to the negative x, negative e to the negative x, uv. And then again, I'm going to have a minus integral of 4e to the negative x times the, well, 4 v du times e to the negative x. So negative times the negative is a positive, so it's going to turn to a positive 4e to the negative x dx. So finally, we're almost done, guys. We have, let's see what we have here. Did I mess up here somewhere? Yeah, I messed up right here. That's a negative. 2x squared negative uv. Okay, now we're good. That should be negative there. Negative, negative. All right, so we're good. Negative 2x squared e to negative x minus 4x e to negative x. And we're doing antiderivative of that, and that exponent is negative, so it's going to be minus 4e to the negative x. And all this is evaluated from 0 to 1. All right, let's do the 1 first. If I plug in a 1, 1, everything's going to add up here, so I'm going to have negative 2e to negative 1 minus 4e to negative 1 minus 4e to negative 1 minus, if I plug in a 0, 0, 0, e to the 0 is 0, so minus negative 4. So that looks like 4, 8, 9, 10, negative 10 e to the negative 1 plus 4. Alright, guys, give that one a shot. Question 10 is brutal. Off the top of my head, I can't think of it. I mean, I did a lot of stuff, and I actually got down to 2 answers, and it was either between B or D. So I'm going to have to look at it again, guys. So I'm going to examine question 10. So let's see how much of this you can get done, guys. Give it a shot. Let's see if we can at least get the gist of it. If you can at least get the first few correct, I'll be happy with that. And that's integration by parts, guys. All right, I hope that made sense. Sorry if I went fast, and that's it, guys. Later.